Well, Dynamic Trio, this is our final video for our class with Dr. Dog. Today we are going to discuss non-parametric design for non-normally distributed datasets.
We are going to teach you about non-parametric design. Parametric refers to methodologies that require normality. Non-parametric refers to methodologies that don't require normality.
Before launching a non-parametric study, you should first determine the distribution of the dataset. If the dataset is normally distributed, parametric methodology is preferred.
You should recall that datasets can be approximately normally distributed. How much is approximately? That is up to the researcher and is determined by the problem.
You should also recall the Likert scale data are not normally distributed. Once you identify your dataset as skewed, you may choose to utilize non-parametric methodologies.
When comparing one variable across two groups, we can use the Mann-Whitney U-Test as a means of comparing two non-normally distributed datasets.
According to Dr. Dog, the Mann-Whitney test will allow us to examine ordinal data as well. This is important since Likert data are often considered to be ordinal.
Non-parametric methodologies arose as findings were challenged when researchers had ignored the fact that datasets were not normally distributed. For this reason, according to Dr. Dog, the non-parametric designs are often said to mimic the parametric designs.
The Mann-Whitney U-Test is a non-parametric test of the null hypothesis of two populations are the same, against the alternate hypothesis that the two populations are not the same.
According to Dr. Dog, normality is required in parametric design, and with ANOVA this is certainly no exception.
The Mann-Whitney U-Test will allow us to examine non-normally distributed and ordinal datasets to make comparisons between two groups of interest.
Assumptions for the Mann-Whitney U-Test state that all observations from both sets are independent of each other, and the dependent variables are at least ordinal.
This process is used to access any dataset for normality regardless of the statistical analysis to be employed.
Just as the ANOVA was required to compare one variable across two or more groups, non-parametric design often requires a similar process. One of the most common tests, according to Dr. Dog, for comparing one variable across multiple groupings is the Kruskal-Wallis test.
The Kruskal-Wallis test is a non-parametric test of the null hypothesis of two or more populations are the same, against the alternate hypothesis that the populations are not the same. The Kruskal-Wallis test will allow us to examine non-normally distributed and ordinal datasets to make comparisons between two or more groups of interest.
The assumptions for the Kruskal-Wallis test suggest that all observations from the sets are independent of each other, and that the dependent variables are at least ordinal.
The protocol for the Kruskal-Wallis includes examination of the dataset of distribution, the descriptives, and the analyses. Your research questions and hypotheses would match those for the ANOVA.
Dynamic Trio, that sums up our discussions on what non-parametric design is all about. It's been great having you as team members, and hopefully we can meet again.
Liam Karen. I've learned a lot from Dr. Dog, and from the both of you. I want to say thank you. I hope to see you soon, and I want to thank my fellow classmates as well.
Yes, classmates, it's been fun working with the two of you. Even though some of the modules taxed our brains, we certainly learned a lot from Dr. Dog.